Behind me is the latest in a series of tests of a new type of propulsion system called a solar sail. This particular sail is very large. It's about 4,000 square feet, and this is only 1/4 of it. In its full size, when it's deployed in space, it'll be almost 17,000 square feet in area and the thickness of a human hair. Now, a solar sail is a propulsion system. It's not a propulsion system that'll get a spacecraft or a rocket off the ground, but once you get into space and you're away from Earth's gravity, having all that thrust of a rocket engine isn't what's as important. What's important is efficiency and being able to get a lot of thrust to travel from one position to another. And a solar sail achieves that by reflecting sunlight, just like a sailboat on the lake reflects the wind. So this solar sail, with its large, lightweight, shiny aluminum coating, behaves just like that sailboat. We've had several test flights of solar sails. The first was in 2010, and it was a small sail called Nano Sail D. It was about 10 square meters. I am the principal investigator for NASA's first interplanetary solar sail mission, which is called Near-Earth Asteroid Scout, which is set to launch on the Artemis I rocket in the next several weeks. That mission will deploy a 925 square foot sail, again the thickness of a human hair, and use that reflected sunlight pressure to take this spacecraft and its science camera, provided by NASA JPL, to study an asteroid after 2 years of flight. The sail deployment test that we just completed here at NASA Marshall was really a test of functionality of the sail. Could you get these 200-foot long booms coiled up, put in a deployer, attached to a sail that has the area of over 4,000 square feet, when it's all folded and rolled, put it in a small box, and get it to deploy unaided? And the answer is yes. We had a very successful test, and the results are evident in the pictures that have been taken and the data we collected during the test. And the key to enabling some of these missions is having larger and larger sails that are very lightweight. And that's why we're moving from sails the size of NEA Scout, 925 square feet, to 17,800 square feet with Solar Cruiser. And in the future, we'll make sails that are even larger still. And the larger the sail, generally speaking, the better it has a capability to do propulsion and higher thrust. Some of the missions that are of interest for solar sailing are things like space weather. Most people on the ground don't really think about it, but spacecraft in space are affected by activities on the sun. And there are solar storms that spread out into the solar system that require advance warning so that our spacecraft can essentially batten down the hatches and be ready to weather the storm. A solar sailcraft can continually thrust along the Sun-Earth line between the Earth and the Sun, closer to the Sun than the current warning satellites, and increase that warning time by up to 50%. Solar sailing captivates the imagination. It's the ultimate green propulsion system. What we're doing is we're maneuvering in space without any fuel, just using the natural environment to get from point A to point B. As long as the sun is shining, we can get propulsion. And the significance of that is there are a lot of science missions that need to be accomplished that cannot be done any other way. It will allow scientists to gain views of the sun's north and south poles on future missions, which we can't study right now. The reason why that's so exciting is I can't imagine trying to understand the Earth's weather systems if we don't know what's happening at the North and South Pole. Scientists are similarly handicapped when they try to study the sun because they don't have near continuous observations of the poles. Now, solar sails are obviously not for everything. Sails are limited to small spacecraft and small payloads. We won't be flying humans with them anytime soon. But that doesn't mean they can't be used to support human missions. In near-Earth space, going to the moon, they can be put into novel orbits to give near continuous communications coverage to the moon. They can give us observations of what's happening on the lunar far side continuously. They give us the capability to maneuver in near-Earth space and take spacecraft from point A to point B repeatedly over years because they don't run out of gas. And eventually, the descendants of this sail that are much larger and much more durable will fly very close to the sun and give us the capability to reach the stars.